Okay, so we're going to review practice problem 1. In this problem, you're using 72 curies of cobalt-60. How much radiation would you receive at a distance of 120 feet? So we know that 1 curie of cobalt-60 equals 14.0 R per hour at 1 foot. So they're not asking us for 1 curie, they're asking us for 72, but that our known is at 1 foot. If we stood 1 foot from a cobalt-60 source for 1 hour, we would pick up 14 R per hour. So they have given us two things in the known. They have given us a known intensity of 14.0 at 1 curie, and they have also given us a known distance of 1 foot. So I can go ahead and put in 1 foot for my distance, which I have to square. 1 times 1 equals 1, and I know that seems silly to even do, but I do it out of habit, because if it's not 1, say they ask for inches, or they give it to you in the problem itself, then you don't want to skip that step. So the next thing is, they're not asking for 1 curie, they're asking for 72 curies. So we have to take 72 curies and multiply it by 14.0 in order to get our first intensity, which would be 1008. Now, our intensity 2, we don't know yet, but if we read the problem, how much radiation would you receive at a distance of 120 feet? When they give us a distance, there's only one other place a distance can go, and that would be right here. So we can go ahead and put that 120 here. But we still have to get rid of this 2, which means we have to square this, and 120 times 120 equals 14,400. So that leaves us with a question mark for intensity 2, which tells us that that's what we're solving for. So now we can go ahead and plug in. I like to have this little equation box here, just so I can go ahead and plug everything in. I will go ahead and plug in my intensity 1. I draw my formula up at the top before I start any problem. That way I can look. Intensity 1, I know, goes right here, and so on. So intensity 1 is 1008. Intensity 2 is what we're solving for, and distance 1 is 1 foot, and distance 2 is 14,400. Now, the objective of this is not to teach you math. As you'll see once I go through the math, this is not a common way to cross multiply and divide, but it is the easiest and fastest way to give you the correct answer. So the next step we're going to do is we're just going to simply cross multiply these two. 1008 times 1. So we're going to multiply. Of course, is 1008. So let me fix that. All right, so 1008. Now, to finish this problem, all we have to do is divide by 14,400. So you would already have 1008 in your calculator because you just multiplied 1008 times 1. And so all you would have to do is hit the divided by button and type in 14,400. So you would go, and that would give you an answer of 0.0 0.07 R per hour at 120 feet. So if you stood at that location for 1 hour, you would pick up 0.07 R per hour. Now, if you had to convert this to MR, just say the answer isn't on the exam that you're taking, but you see something similar, try converting it to MR, which is millirankins, and you might just see that answer there. So I'm going to go ahead and show you. Convert to MR per hour. All you have to do is move this decimal 3 places, and your new answer would be 70 MR per hour at 120 feet. You can also simply just multiply times 1,000, and you'll get the same answer. So if you had 0.07 times 1,000, give you 70 MR an hour. So that's a way. So if you don't see 0.07 on your exam, see if you see 70 millirankins. So your answer to this problem is 0.07 R per hour at 120 feet. Now again, I'm not here to teach you math. I'm here to teach you how to solve this problem the quickest and easiest way. So use this as a refresher, and hopefully it helps you out. We'll move into time and also get into some have value layers as we go on. But for now, this is solving for intensity.